It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitt with Fort Bend Tutoring, and today we have a tutorial for you on row operations. That's right, row operations that are conducted on matrices. But before we begin, go ahead and click on that subscribe button, please. And as well, go ahead and click on the bell icon so that you can be notified when we're uploading new and fresh content just for you. That's right. Go ahead and subscribe, please. I'll wait. Okay, thank you. Great. And let's go ahead and begin with some rules about row operations. Let's start with the fact that for any real number k in any augmented matrix of a system of linear equations, the following operations will produce the matrix of an equivalent system. Number one, interchanging any two rows of a matrix will result in an equivalent system. That means that you can swap out any two rows of a matrix and your answer will not change. That is correct. Let's see about number two. With number two, it says multiplying the elements of any row of a matrix by the same non-zero number k will also result in an equivalent system. Yeah, you can multiply any row by any non-zero number k and the result of the system will not change. Good to know. Number three, adding a multiple of the elements of one row to the elements of another row will result in an equivalent system. Let's say that I multiply one row by 3 and then add it to another row. It will not change the answer to a system of linear equations. Yeah, this is good stuff, guys. Make sure that you have these rules in mind when doing row operations of an augmented matrix. That's right. And so let us continue. And speaking of augmented matrices, go ahead and check out our video on augmented matrices so that you can be up to date on the terminology that is used within this video. All right, well, we have problem number one here, guys, and we have a matrix that contains the elements 3, 6, 2, 11, 7, 6, 1, 4, and negative 6. And what does this mean right here? This notation that you see to the right of the matrix, it means that they want us to swap out row 1 with row 3. Well, let's go ahead and make that happen then. So what I'm going to do is I'm going to bring down the rule that we're attempting to do here. That's swapping out of row 1 and row 3. And then with my matrix, I'm going to write down the row that will not be changed first. So I found that in trying to be consistently accurate in doing row operations, that when I write down the row that's not affected by the rule, then my answer tends to be correct more often than not. So please understand that when doing row operations, the first row is notated as row 1, the second row is notated as row 2, and then of course the third row is notated as row 3. This particular rule says to swap out row 1 with row 3. So that means that row 2 is unaffected. So we're going to be bringing down 11, 7, and 6 from our original matrix. And what I'll then do is I'm going to be swapping out row 3 and row 1. So instead of writing the original row 1 here, it'll now be 1, 4, and negative 6. In other words, that row 3 from the original matrix is now placed as row 1 in our new matrix. That's correct. Then our third row will now be 3, 6, and 2. Yeah, that's it. Red box it. You got it, guys. This is the answer. Yeah, and we like to put our answers in red boxes so that no one will have a hard time finding the result. There you go. That was problem number one, guys. Let's move on. Here we have problem number two. And in problem number two, we obviously have our matrix here, right? For the problem two. But we also have a new rule. And it says that we would need to add row 1 plus row 2 and then put the result of that where row 2 is. So what does that mean to me? That means that row 1 and row 3 are unaffected by this rule. That's right. And because of that fact, I'm going to be going ahead and starting out my result here by rewriting row 1 and row 3 as they are unchanged by the rule that they're asking us to do here. The operations that they're asking us to do to this matrix, in other words, adding row 1 plus row 2 and then putting our result in row 2 does not change the original row 1, nor does it change the original row 3 of our matrix. There you go. So what we'll do then is we'll be adding the elements from row 1 and row 2 together. And of course, we'll be adding those corresponding elements. So the first element in row 1 will be added to the first element in row 2, and I'll continue that process throughout the operation here. And we'll be placing the result in row 2 of our resultant matrix. All right, so let's get started. 1 plus 0, that's 1. 4 plus 3 gives us 7. And negative 2 plus 5 is positive 3. We place the sum of row 1 and row 2 in row 2. And that's exactly what they asked us to do. So let's go ahead and make that note that row 1 plus row 2 was placed in row 2. And that's what happened. Red, box it. And here we have our result, guys. Done and done. That was example 2. Let's keep it moving. Continuing on, I would want to remind you guys that you can set up a paid online tutorial today with me, Mr. Whitt, and Fort Bend Tutoring by checking out our website at fortbendtutoring.com. That's right. You can check us out there and set up a paid online math tutorial with me. And I can help prepare you for your upcoming tests, quizzes, as well as help you out with your homework. Just an FYI from your boy, Mr. Whitt. Back to the lesson. We have problem number 3 with a 2 by 2 matrix. That's the order that I'm referring to. 2 rows and 2 columns. And the rule that they're asking us to do is to take half of the values of the elements in row 2 and then place the result in row 2. You can also write this as row 2 divided by 2 and then place the result of that in row 2. So just a couple of ways of how the rule can be written in problem number 3, guys. Let's go ahead and take a look at this. Well, let's go ahead and understand that 1, we're going to be having a 2 by 2 matrix as the resultant matrix, and that the result of this is going to be from us dividing every element in row 2 and then placing it in row 2. So I'm writing this rule out to the side just as a reminder of what actually happened or what was asked of me. Also, I'm going to be rewriting row 1 because it's unaffected by this rule. Notice that they're asking me to place the result of the division of row 2 divided by 2 into our row 2 location. So that means that row 1 is unaffected. So I'm going to be bringing down the 1 and then the negative 3. And I just find that it's a personal preference of mine to write down the unaffected rows first. It just increases my accuracy as far as writing the answer. Now let's get back to what they actually want us to do. And that is to take the elements in row 2 and take half of them. Yeah, they want us to divide them by 2. And so we shall. What's 4 divided by 2? Well, it's 2, right? And what's 6 divided by 2? Well, it's 3, isn't it? So that means that we're at the answer, guys. Red, box it. That's right. We have our answer in a box. Done and done, people. Let's move on to problem number 4. In problem number 4, we have a 3 by 3 matrix, and our rule that they're asking for is, oh, I'm sorry, I don't like this 3. Hello. This 3 is ugly. Let's fix this horrendous 3. There you go. That's a much better 3 now, isn't it? Okay, back to business. Here we have a 3 by 3 matrix, and the rule is to find the opposite of row 3 and then add that to row 1 and then place the result in row 1. All right, so in the resultant matrix that I'll be showing, I'm going to show that I'm going to be placing the opposite of row 3 plus row 1 into row 1. Okay, and that also means that row 2 and row 3 are unaffected by this. So that means I'm going to just bring down row 2 as 1, 6, and 7, as well as row 3, which is 10, negative 4, and negative 1. Okay, so what's coming up next is the fact that I'll be taking the opposite of row 3 and then adding it to row 1. So what does that mean? That means that this positive 10, because of the opposite, will become negative 10. And then negative 10 plus negative 3 gives me negative 13 as I write the result in row 1. Just like that. Then I'll be looking at the next term in row 3 and finding the opposite of that. So the opposite of negative 4 is positive 4. Then adding 4 plus 0, we end up with positive 4 as I write that in my new row 1. Finally, the last term in row 3, we'll find the opposite of negative 1, which is positive 1, and then add positive 1 to 12 to get 13 as the final element in our new row 1. Red, box it. Just like that, guys. Just going through these row operations for our matrices. That means we're moving on to our next problem, which is problem number 5. So what I wanted to show in problem number 5, guys, is that sometimes they can literally just write out the row operation that they would like for you to do. So to show you the shorthand for this, when they say negative 2 times row 1, added to row 2, we would shorten that into negative 2 row 1 plus row 2, and then we'll be placing the result in row 2. So notice that they didn't include that extra bit of replacing row 2 with the result. That means that it is implied when they write it this way. So you have negative 2 times row 1 added to row 2. Generally, the last row that they mentioned is where you'll be writing that resultant row. So let's go ahead and start by writing down this rule. This negative 2 row 1 plus row 2, placing it into row 2, knowing that in my 2 by 2 matrix here, that row 1 is unaffected. So we'll just bring down that positive 2 and positive 4 here. So then they're asking us to multiply the original row 1 by negative 2 and then add that to row 2, and then of course place the result in row 2. We're going to be multiplying 2 times negative 2. That's going to give us negative 4, right? And then negative 4 plus 4 gives you 0. Let's look at that again. We're going to be multiplying 2 times negative 2 because we're looking to multiply every element in row 1 by negative 2. And then we add that value to the corresponding element in row 2 and then write the result of that in our resultant matrix here. There we go. So we had negative 2 times 2 gives us negative 4. Then negative 4 plus 4 gives you 0 for that first element in the second row of our resultant matrix. Next, we'll be multiplying 4 times negative 2. So negative 2 times 4 gives you negative 8. Then negative 8 plus 7 gives you negative 1. So you have negative 1 as the last element in row 2 of your resultant matrix. Red, box it, people. There you go. Protect your answer from harm by placing it in a patented FBT red box. Thank you. And you can have your own FBT red box for $5.99. Just check out our website. That was a joke, people. Problem number 6. In problem number 6, we have a 2 by 2 matrix where we're asked to find 7 times row 1 added to row 2, and we're going to put the result in row 2, just like that. Okay, so let's go ahead and set this up by saying we have 7 times row 1 plus row 2, placing that result in row 2. Here comes our resultant matrix here. Which row is unaffected by all of this? Row 1. So I'll be bringing down negative 1 and positive 4 for our row 1. Then I'll be multiplying the original row 1 times 7 and adding that to row 2. So negative 1 times 7 is negative 7. Negative 7 plus 7 gives me 0. Then I'll be multiplying 7 times 4 to get 28, and then 28 plus 0 gives me 28. Red, box it, people. There you go. And we have our result of problem number 6. After multiplying row 1 times 7 and adding it to row 2 and then placing it in row 2 of our resultant matrix. Amen, amen. Let's move on to problem number 7. Here we go. In problem number 7, we have a 2 by 2 matrix, and the row operation is negative 5 times row 1 added to row 2. So that rule looks like this. Negative 5 row 1 plus row 2, and we'll be placing the result in row 2. So let's get to it. I have negative 5 row 1 plus row 2, placing that answer in row 2. In a 2 by 2 matrix, by the way. So that means that row 1 is unaffected by this. So I'll just bring down the 1 and the 1/5 as it is, just like that. Then we'll be multiplying row 1 times negative 5 and then adding that to row 2. So negative 5 times 1 is negative 5. Negative 5 plus 5 gives me 0. Then we'll be multiplying negative 5 times 1/5. Well, negative 5 times 1/5 is negative 1. Negative 1 plus 2 leaves me with positive 1 as a result. That's right. Let's go ahead and take our time with that. Let's go ahead and show that when you have negative 5 times 1/5 and you add to that positive 2, the 5's cancel out here to leave you with negative 1 plus 2, which equals to positive 1 as a result for that particular element that ended up in row 2, column 2. All right. Red, box it, people. There you go. And this is going to be our resultant matrix for example 7. Moving along. We have problem number 8. In problem number 8, we have a 2x2 matrix, people. That's right. And the rule would be 4/7 row 1 plus row 2, placing the result in row 2. Yeah, that's what we have for problem number 8. So I'm going to show that this rule that we're applying here, okay, and then rewriting it in row 2, that row 1 is unaffected. So that means I'm going to be rewriting row 1 first. So I have 5 and 7. Just like that, guys. You hate that 5 too? So do I. Let's fix it. A better 5. Yeah, look at that. And I got that little crest on the top of that 5 there. What you think about that crest? What you think about that? He over there peacocking? Oh, he looking good, y'all. Yes, he is. That's a good looking 5. Go ahead and tell me about my number 5 right there. Tell me about my number 5 in the comments. See if you like that. Can you do a better 5? I'm just saying. My 5 look kind of cool right there. It's a cool 5. We're going to move on. We're going to be multiplying row 1 by 4/7 and then adding the result to row 2. So let's see what this looks like. We're going to have 4/7 times this first element of 5. And then we'll be adding to that 2. Yeah. So that gives me 27ths. And then rewriting 2 with a denominator of 7 is 14/7. All right. And then adding that together, that gives you 34/7 as the new element for row 2. So 34/7 belongs right there, guys. There you go. That's how we got it. Then applying that same strategy to the next element, you'll have 4/7 times 7 plus -4. For this element, your 7's will cancel out and you're left with 4 minus 4, which is 0. So here you end up with 0 for your final element in your resultant matrix. Red, box it, people. There you go. So as you need to, you can go ahead and show your work for how you're getting each of the elements, especially when things get a little bit complicated. All right. So don't be afraid to write it down prior to writing down your result. And on to problem number 9. For problem number 9, we have a 3x3 matrix, and the rule is -5 times row 2 added to row 3. So we'll be placing the result of this rule in row 3 here. So there we go. So -5 times row 2 added to row 3 is underway, guys. We're going to start by writing our rule here, the -5 row 2 plus row 3, all of that going into row 3 as we finish things up. And I'll be starting out with my matrix. There we go. This rule tells me that row 1 and row 2 will be going unaffected. That's right. Since we'll be putting the resultant of this operation in row 3. That means that row 1 can remain as -3, 1, and -4. And row 2 remains as 2, 1, +3. And then when it comes to row 3 in our resultant matrix, we'll need to multiply -5 times 2, then add -7 to this. Okay, so that means that we'll have -10 minus 7 to give us a result of -17 for that first element in our new row 3. Then we'll continue on by multiplying -5 times 1 and then adding 5 to that product. So you'll end up with -5 plus 5, and we know that that equals to 0, just like that. Finally, you have -5 times 3 plus 2. Well, this is negative 15 plus 2, which gives us a result of negative 13. So we have negative 13 here for our final element in our resultant matrix. Just to recap, guys, what we did in this problem was multiplied each of the elements in row 2 by negative 5. Then we added those values to every corresponding element in row 3, and then wrote our result in our new row 3. Red, box it, people. There you go. This is our answer for problem number 9. Moving on. In problem number 10, we have a 3 by 3 matrix. The row operation is to multiply negative 6 times row 3 and add that to row 1, and we'll be placing our result in row 1. So that means I'll begin by writing down this rule, negative 6 times row 3 plus row 1, putting the result in row 1, and then opening up my resultant matrix here. In this problem, I know that row 2 and row 3 will go unchanged because I'll be placing the result of this operation in row 1. So I'll be bringing down 4, negative 1, 2, and for my row 2, and for row 3, I'll keep the 3, 7, and 1. The only thing that will be changed is row 1. So we'll get these new elements by multiplying negative 6 times each of the elements in row 3, then adding that product to the elements in row 1. So I'll begin with negative 6 times 3 plus 2. This gives me negative 18 plus 2, which gives me a result of negative 16. Once again, we multiplied negative 6 times the elements in row 3, and then added that to row 1, then wrote the result in row 1 in our resultant matrix. Next, we'll be multiplying negative 6 times 7, and then adding that product to 5. So negative 6 times 7 is negative 42, and then negative 42 plus 5 gives you negative 37. Just like that, guys. We multiply negative 6 times 7 to give us negative 42. Negative 42 plus 5 gives you negative 37. There you have it. Next up, we'll be multiplying negative 6 times 1 and then adding 6 to that product. So negative 6 times 1 gives you negative 6. Negative 6 plus 6 is 0, people. Just like that. Red, box it, y'all. Just like that. We have problem number 10 done and done, and moving on. Next, we have problem number 11. And in number 11, it says for us to multiply 2 times row 1, add that to row 3, and put the result in row 3. So this is a 3 by 3 matrix, guys. And the result is going to go in row 3. So I'm going to be rewriting this as 2 times row 1 plus row 3. Put that result in row 3. So here comes my resultant matrix. I do know that row 1 and row 2 is unchanged, so I'll be bringing that down. We have 1, 5, 6 coming down along with negative 2, 3, and negative 1. That's right. Look at the forehead on that 3. Let's go ahead and fix it. Fixing the big head on that 3. All right. Well, see, that's better. That's a much better looking 3. Yeah, I know you can't do better than that. So we're going to be moving on. Okay, let's move on now. We'll have 2 times row 1. Add that to row 3. Put the result in row 3. So we'll have 2 times row 1 plus 4 is basically what I'm looking at here. So this gives me 2 plus 4. That gives me 6. There we go. Pick up the sticks. Then you're going to say 2 times 5 plus 7. So multiplying 2 times our second element in row 1, then adding that to the corresponding element in row 3. So you have 2 times 5 is 10. 10 plus 7 gives you 17, people. There you go. Just like that. Finally, we'll have 2 times 6. And we'll be adding 0 to that. So multiply 2 times 6 to get 12. And then 12 plus 0 gives you 12. Just like that. Red, box it, people. There you go. Go ahead and put a nice box around your answer. Next up, We have problem number 12, and we have a 3 by 3 matrix, guys. They have a rule that says -4 times row 3 added to row 2 will be placing the result in row 2, people. That's right. So here, as I have my setup, I'll have -4 row 3 plus row 2, placing the result in row 2, and here is my resultant matrix. In this problem, guys, row 1 and row 3 will go unchanged. So we'll have 4, 10, and -8 for the first row of our resultant matrix. Also, row 3 will go unchanged. So we have -1, 1, and 0 for our third row in the resultant matrix. As far as row 2 is concerned, we're supposed to be taking row 3, multiplying it by -4, and then adding it to row 2, guys. So you'll have -4 times -1 plus 7 for your first term in row 2. So that's going to be -4 times -1 gives you +4. +4 plus 7 is 11, people. There you go. Enjoy that one. Then you'll have -4 times 1 plus 4. So this gives you -4 times 1 is -4. -4 plus 4 is 0. That's right. That's right. Finally, you'll have -4 times 0 plus 3. So multiplying 0 times -4 gives you 0, of course. And then 0 plus 3 is 3. And this is the answer for problem number 12. Red, box it, people. Just like that. You got it. And that is our answer for problem number 12. Yeah. We started out with our rule. -4 times row 3 added to row 2. So then I wrote it in its abbreviated form as -4 row 3 plus row 2, replacing the original row 2 with that resultant row. There you go. Then we handled our business as we do, and red boxed it. That's what happened, people. Well, all right, guys. Do not forget to subscribe to the YouTube channel Fort Bend Tutoring FBT with your boy, Mr. Whitt. How you doing? How you doing, people? And as always, please like, comment, and share the video with a few people that you like, your classmates, and a couple of people that you hate. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutormemath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.